So we're going to practice, when is this pretty picture that I drew? When is this increasing? When is this decreasing? And when is this constant? Okay, when is it increasing? When is it decreasing? When is it constant? So if you think about reading this thing from left to right, you can see that that graph is going upwards until it hits right here at the top. And then from here to here, it's going to be going downwards till it hits about right here. And then from then on, it's going to be going upwards again. So it's going to be increasing from negative infinity until negative 2. So remember, you're telling me width. You're not telling me height. I don't care how tall it is. I just care about when it's going up, when it's going down. So from negative infinity all the way till it hits negative 2, it's going to be going up. And then when is it going up again? From positive 2 all the way for the rest of its life, it will be going up. So from 2 to positive infinity, it will also be increasing. Well, when is it decreasing? So from here all the way to here, it's decreasing. So from negative 2 to positive 2, it's decreasing. When is it constant? It's not. Okay, when is it constant? It is not. So let's try another one. If I have something like this, yeah, it's supposed to, this is a really bad drawing. All right, so let's say that that point and that point are at negative 1 and positive 1. Okay, so when is it decreasing? So as I read it from left to right, it's coming down from negative infinity to negative 1. So negative infinity to negative 1. When is it increasing? Well, I'm going to keep reading it this way. When does it start going back up? From positive 1 for the rest of its life, it will be increasing. And then when is it constant? When does it not go up or down? So between negative 1 and positive 1, it's flat. So constant is going to be from negative 1 to positive 1 because it has no change. It doesn't go up or down. It's just flat. Now, let's just for a second talk about, hang on, I'm looking for colored pens. All right. Ooh, look, green. All right. So let's talk about the value or the sign of the derivative. So if I'm reading this and this is increasing, remember that the derivative is the formula for slope of the tangent line. So regardless of where you would draw a tangent line through here, it's going to be a positive slope. So if your function is increasing, your derivative will be positive. Okay, if your function is decreasing, so remember that the derivative is the formula for slope for any tangent line on the curve. Okay, so if my function is going down, my tangent lines will have negative slopes. If my function is constant, that means it's not going up or down. So the value of the derivative will be 0. So I could ask you, come back up here, I could say, well, what's the value of the derivative at, let's just say negative 5. Okay. Is it going to be positive or negative? So at negative 5, which is over here, okay, I know my function is increasing, so my derivative will be positive. What if I ask you what's the value of the derivative or the sign of the derivative at 3? Okay, well at 3, what's happening at 3? Here's an x value of 3 and my graph is increasing, so again, it'll be positive. So the value of the derivative, if it's positive, it means your function is increasing. If it's negative, it means your function is decreasing. So if I ask you, is it at negative 1? Okay, so here's a tangent line at negative 1. So you're going to have a negative derivative because your function is decreasing. Okay, and then here, it's going to be 0 because it's constant. Okay, so those are just kind of sort of ways that we can interpret graphs and interpret the signs of the derivative, if it's positive or negative or 0. So you got some to do in there. All right, so you can do that. All right, so now we're going to do actual practice with how do I make this thing work, okay? How do I make this work? So I have a function. And my function is 7 minus 3x. Okay, I want to know the intervals where it's increasing and the intervals where it's decreasing. So step 1 is going to be take a derivative. So differentiate. Step 2 is going to be to get points where your derivative equals 0. Okay, points where your derivative is equal 0. And then you want to make a number line like what we did in the first video and just take test points on the intervals. Okay, so step number 1, I have this function. Step number 2, or step number 1, sorry, is take a derivative. So the derivative of 7 is 0. The derivative of negative 3x is negative 3. Okay, so I want to make my derivative equal 0. It is impossible to make negative 3 equal 0. What that means is this function is always decreasing. Always. Well, what does this make if I graph it? This makes a line that slices through the y-axis at 7 and has a slope of negative 3. What happens if you watch that line? It just goes down forever and ever and ever. So where is he decreasing? He's decreasing his entire life. Where is he increasing? He doesn't. He does not increase. Okay, so let's do another one. We have f of x equals x squared minus 5x. All right, so this is not a line. It's not going to be as easy. I do know it's a parabola. I also know it's opening upwards. So I know he's going to have this shape. Okay, now, what is step 1? Step 1 says take a derivative. So I get 2x minus 5. Once I know what the derivative is, set it equal to 0 and solve it. So I'm going to add 5 to both sides, and then I'm going to divide both sides by 2. So I get x equals 5 halves. That is where your derivative will equal 0. Okay? So it's not positive and it's not negative. So I'm going to have a point here. We call this a critical number. Okay, wherever your derivative is 0 or wherever your derivative is undefined, we call those critical numbers. So at this critical number, I now have an infinite number of numbers to the right, and I got an infinite number of numbers to the left. I just need to pick one, okay, on each side. So, and then I'm going to test it in this original derivative. Okay, if I get a positive answer, it's increasing. If I get a negative answer, it's decreasing. So give me a nice friendly number to the left of 2.5. Let's try 0. So 2 times 0 is 0, minus 5 is negative. So that means your function is going to be decreasing. Okay, give me a nice friendly number after 2.5. Let's try 10. Okay, 2 times 10 is 20, minus 5 is 15, which is positive. Okay, so you effectively just drew the parabola. Remember, I don't care what points you grab. There's an infinite number to choose from. I just grab friendly ones. So where is he decreasing? He will be decreasing from negative infinity until he gets to 5 halves. Where will he be increasing? It'll be from 5 halves to positive infinity. Okay, so that is your intervals where he's going up and down. All right, so let's try another one. I always say the same things when I'm making videos. All right, what is my function? My function is 8x squared plus 7x. And then plus 3. So again, I notice it's a parabola. I want to know where he's increasing and decreasing. So I'm going to take a derivative, set it equal to 0, so I can find intervals for my test points. So my derivative is a 16x plus 7. Set that equal to 0, so I'm going to subtract 7 and divide by 16. So I get negative 7/16, which is right about negative 1/2. Okay, estimating. So draw your little number line. Your critical number, or the point that we're interested in, is negative 16ths. So grab me a point to the left. I don't care what it is. I just care it's to the left. So give me a negative 10. Shove that into your derivative. So 16 times negative 10 is negative 160, plus 7 is negative. I don't even care what it is. I just care that it's negative. Give me a nice friendly number after negative 16ths. Well, how about 0? 16 times 0 is 0, plus 7 is positive. So he will be increasing. So where is he decreasing? From negative infinity to negative 7/16. Where is he increasing? From negative 16ths to positive infinity. All right, let's go a little bit more exciting. We got some fractions going on. So my function is 5/3 x to the third minus 15/2 x squared. And I want to know the intervals where it's increasing and decreasing. So the first thing I'm going to do is take a derivative. So drop your 3 out front, which means it will reduce with this 3. And that's going to leave you with 5x squared. Drop your 2 out front, and that's going to reduce with this 2. So it gives you negative 15x to the first. And now I need to set that equal to 0 and solve. Okay, so the other ones were pretty basic. Okay, I can do stuff in my head. Notice I can divide everything by 5. So I'm going to divide everything by 5, which is going to give me x squared minus 3x is 0. And you don't have to do that. It's just going to make your life a little bit easier. You can also put your test values in here. Okay, you can also put your test values in there. So all I did was divide by a constant. So it didn't change what it is. It just changed how, if you remember, a constant will just tell you how tall or how skinny that parabola is. So a constant multiple will just make it wider or narrower. It doesn't change the fact that it's a parabola. Okay. So that being said, how do I set this thing equal to 0? I'm going to factor out an x. That gives me an x minus 3 equals 0. So now my interval, I've got 2 values. This one can be 0, and this one can be 3. So I've got 3 intervals this time that I need test numbers for, and I'm just going to shove my test numbers up in here. So a fabulous number to the left of 0, let's do negative 10. So negative 10 squared is 100, minus 3 times negative 10 is going to be plus 30. So that gives me positive. Okay, a number between 0 and 3, let's do 1. So 1 minus 3 is negative. And a number after 3, let's just do 10. So 10 squared is 100, minus 30 is still positive. And now you've drawn your intervals. So where is he increasing? Oops, that says in. He will be increasing from negative infinity until 0. And then again from 3 to positive infinity. So you should have a union symbol in there. Okay, let me rewrite. He says negative infinity to 0, and again from 3 to positive infinity. Okay, where is he decreasing? He's decreasing between 0 and 3. So he's decreasing from 0 to 3. All right. So that one, let's stop and I'll do the last few on a second video.